All right, we looked now at the Voronoi fracturing in detail, the RBD material fracturing in detail. Let's now look at the Boolean fracture that we talked about in the beginning. And this allows you to really art direct your fracturing to the very last point. Now we've seen in the last video, this is kind of already built in the RBD material fracture. So let's start where we stopped. So we can actually use our own grid. Let's say we move it here. Let's adjust it a little bit to the right size, maybe 2 by 2 meters, something like that. Yeah, about right. And we can use this as a fourth input if we change our RBD material fracture from concrete to custom. And then, even though we will talk about the scatter cutting geo under primary fracture more, let's turn this off for now and just use the input cutting geometry. And what you can see is we can define exactly where our cut should happen, and even how the, as you can see when we use an exploded view, how the surface should be built, because this is directly controlled by the resolution of our grid. So if we change the resolution here, you can see we change the surface of our cutting area. Now this is, as we've seen, built in the RBD material fracture, but there's no need to actually use the RBD material fracture for a case like this. You might already remember what this feels like, and you're right, this is basically a Boolean. This is why it's called a Boolean fracture. So we could use a normal Boolean with the same inputs, and just make sure that in the Boolean, our second input is treated as a surface. And you can see here, you get the same result. The advantage here is that you don't have to click through all these things in the RBD material fracture. You can just use it directly. The only disadvantage of using a Boolean node here, even though as you can see, it perfectly works, is that you will not get any constraints between the pieces. And this is an advantage of the RBD material fracture. You can see here that those two pieces that we just created are actually connected with a constraint. So RBD material fracture is the way to go, right? Now there is actually something in between, and that is the Boolean. You might have already seen it, Boolean fracture. There we go. There's an actual node for this that works the same way. And this is actually the node that you would find inside of the RBD material fracture. As we know, this is just a big pre-built bunch of nodes. And the node that we're currently using is the Boolean fracture. So let's use this instead. And here we go. We now have the constraint between those pieces as well. So this is the core idea. You can really control directly where the cut should be, and if you don't like it, you can very quickly change it. This is something I like about it. At least when you have just a few pieces like this, it's super fast. So this is really nice to work with as well. The only disadvantage is that you actually have to specifically set every single cut. So first of all, a single cut, of course, is pretty boring. So to keep it a bit lightweight, let's lower the resolution of our cutting grid here, maybe to something like this. And what we can do, of course, is we can just use multiple grids, so this one, and then merge them together and use that as an input. And here you can see now that we can really, in detail, define, actually let's lower the strength of the exploded view, maybe something like this. We can really define specifically where every single cut should be. So for example, if you want to cut here down in the corner, you can do that by just positioning a grid there. Then we add another one that is supposed to cut right in the middle of this one, and so on. So this is really helpful if you want to really art direct your pieces. And this is the reason why most senior FXTDs you will see using the Boolean fracture. Another thing is, by the way, you can, of course, instead of setting every single piece yourself, use a copy and transform and rotate each piece. Unfortunately, what you can see is that it will transform relative to the 0 point, which you can solve by just putting it back to 0 and then transform it afterwards. But you can also use, by the way, not use the CEX. This will throw an error, unfortunately. But you could use the centroid of the grid 8 in our case. So this way you could make sure that it actually takes the center of the input, and then 0, 1, 2 represents X, Y, and Z. Sorry, I know this was a bit fast, but this is just a side note if you run into this problem. Instead of reading out the center of the copy node, we're basically reading out the center of the grid node. Just look up the centroid expression. We will use this later on in other contexts. But for now, this can be a solution, and then you can add multiple copies of this basically. And this way you can create a lot of surfaces yourself by just copying the original one. Now, if this looks familiar, this of course is how internally the RBD material fracture works if you don't use an input geo. The scatter cutting geo basically does the same, only it uses points to copy the pieces on, which is another thing you can do here. So my point here really is there are a lot of ways of creating all those cutting surfaces. Be a bit creative, use the copy and transform, use a scatter maybe that you copy the pieces onto. You don't have to manually set every single one if you don't want to. It's just an option. And then as you can see here, you can get a very kind of pseudo random result as well without having to position every single surface yourself. And by the way, especially for the Boolean fracture, there is a node that is actually even better than the exploded view, because we want to have those constraints here. There is actually explicitly, you might have already noticed it, an RBD exploded view for a couple of versions now, which when you connect the constraints as well, allows us to use it like a normal exploded view, but by turning on show constraints, you can even visualize the constrained version of the exploded view. So the constraints scale with it, and you can see how the pieces are connected. Can be really helpful for debugging your setups. So the RBD exploded view is something you usually work when working with a Boolean fracture. Now, another thing I want to talk about, and for this let's go back to a simpler version of this. As we've seen before, and this is something we will talk about in a later video very soon, I think, that is additional detail to our destruction here. And this is mainly surface detail and edge detail. What do I mean by that? If you look at the actual cutting area here, you can see that the resolution or the topology of the grid here is represented in the cutting area. This is a great thing actually, because this is kind of already built in the Boolean fracture. You can control the surface as well with your cutting geometry. And this becomes especially interesting when you deform it with a mount node, for example, because now you can see that the surface is not just flat, but it's actually broken up and it feels much more like a concrete. This is not the only way of doing this. In the detail interior video, we will look at ways of doing the same for RBD material fracture, where it's built in, and the Voronoi fracture. So don't worry, this is possible with all the other techniques as well. But with the Boolean fracture, this is kind of inherently already built in with a cutted surface. And the cool thing here is it's not only the surface that is broken up here, but also the edges actually. So here you can see, because our geometry was deformed, we also get a deformed cutting edge. And this is something the RBD material fracture can do, but not the Voronoi fracture. So this is really another advantage of the Boolean fracture. You get the detail already built in the cutting geometry. It's simple to understand, pretty straightforward in its use, and at the same time really powerful. And of course, as we've seen before, this also works for something more complex, like our sculpture here. And in my case, I kind of manually created all those pieces here. So this is how it can look like, maybe even more complex than that. And when you run the whole thing, you can see that there's quite a certain complexity to your pieces that you would expect from an RBD material fracture, but with a Boolean fracture, you can get it as well with way more control. So as you can see, there isn't too much you can actually say about the Boolean fracture because it's so straightforward, and this is one of the reasons why I like it. Maybe one last thing, sometimes you have to be a little bit careful with the Boolean fracture. It does not automatically create convex shapes. So when we look at what this is actually simulated with, under visualization show collision shape, you can see sometimes like this piece here is actually much more concave than the representation. So keep that in mind. The Boolean fracture doesn't take care of convex shapes for you. This is something you might have to control yourself with a convex decomposition, for example. Okay, so I hope this is helpful. If you see more complex courses or complex tutorials online that are dealing with RBD destruction, you will probably find the Boolean fracture is a very common node. So I hope this is helpful. Thanks very much and see you later. Cheers.